This video is about mass number and calculating the number of neutrons using Euclid notation. Might sound a wee bit complicated at first, but trust me, it's really quite simple. First of all, what we're going to do is have a little look at the structure of the atom, because to understand calculating the mass number, we need to remember a few facts about the different particles in the atom. What we need to remember for each particle is their location, mass and charge. Really, it's the mass that's relevant to mass number, but this is just a summary of all the information you need to know about the atom. So, location, if you've watched my last couple of videos and if you know a little bit about the atom, you should be able to do that quite easily. Having a little look at our current model of the atom, we can see that we've got protons and neutrons in the nucleus of the atom and electrons orbiting the nucleus in electron shells or energy levels. So, location's nice and easy. Hopefully you can remember the charge of each particle as well. So have a little think about that just now. See if you can remember the charge of a proton, neutron and an electron. Okay, hopefully you can remember that a proton is positive, and we say that a proton has a charge of +1. Neutrons are the neutral particle in an atom. They have a 0 net charge. And electrons are negative. So because electrons and protons have the same value but opposite charges, that's why we give them a value of +1 and -1. So they're the same but opposite. Protons positive, electrons negative. Right, so the mass is something we haven't talked about much before, but hopefully from your research into the structure of the atom, you remember that Rutherford discovered, I think it was about 1911, that most of the mass of an atom is concentrated in the nucleus. Further experiments, when James Chadwick discovered the neutron, showed that protons and neutrons have a very, very similar mass. If you want the actual number in kilograms, here it is. 1.67 times 10 to the minus 27 kilogram is roughly the mass of a proton, and a neutron's roughly the same. But to save us writing that really complicated number out every single time in chemistry, we give the protons and neutrons a mass on a relative scale. So we just give each one, we say it's got a relative mass of 1, and the units of that, like I say, it's a relative scale, we call them atomic mass units, or we could say AMU for that. And electrons, they have a tiny, tiny, tiny mass, but it's so many times smaller than even the very tiny mass of a proton and neutron that we basically say they have a mass of 0. It's not quite true, it's a tiny, tiny, tiny mass, but compared to the proton and neutron, their mass isn't very important. So this is quite important for us when we're studying atoms, because if protons and neutrons each have a mass of 1, then the total number of protons and neutrons in the atom will tell us the overall mass of the atom, and that's what we're going to look at next. So, we can give an atom something called the mass number. Basically that just means the mass of the atom on the relative atomic mass scale, the AMU scale. The mass number is given by the number of protons plus the number of neutrons in the atom. So, for example, if I have this atom of lithium, I've got 3 protons, and you can see there's 4 circles I've drawn in the nucleus to represent the neutrons, 4 neutrons. 3 plus 4 equals 7, so the mass number of this lithium atom is 7. Now, that's fine if you're given a picture of an atom with the number of protons and neutrons, or if you're told the number of protons and neutrons in the atom. More often than not, though, we're not given a picture like this, and we're not told the number of neutrons. More often than not, what we're actually told is the mass number, and then the other piece of information that we can get from the periodic table is the atomic number of an atom. So what I'm going to talk about is how to calculate the number of neutrons if you're given the mass number and the atomic number. So remember, the atomic number is the same as the number of protons. So actually, just by rearranging this top equation, we've said the number of neutrons is the mass number, take away the number of protons. We can make that a little bit simpler by saying the number of neutrons is the mass number take away the atomic number, because remember the number of protons is the same as the atomic number. This is something that you must remember either at National 4 and at National 5 level. You've got to remember that the number of neutrons is the mass number, take away the atomic number. So the way you're often presented this information is in the form of a symbol for the element with two numbers to the left-hand side. The top number is always the mass number. You can kind of remember it, I think about it as the mass number is always the higher number and the top number is higher up on the page. So the top number is the mass number. And remember the mass number is the number of protons plus the number of neutrons. The bottom number is the atomic number. Remember the atomic number is the same as the number of protons. So if I was to have to calculate the number of neutrons for this lithium atom when I'm given the mass number and the atomic number, the number of neutrons is simply the mass number take away the atomic number. I always think it's the higher number take away the lower number. 7 take away 3, so there are 4 neutrons in this atom. Okay, I'm just going to very briefly run through the first couple of examples in the exercises that I'd asked you to do, and then you'll do the rest of the page yourselves. So, the first one is actually the one that I had just done. So we're given the symbol for lithium. Remember the top number is the mass number, the bottom number is the atomic number. So, first two boxes, really easy to complete. Atomic number 3, mass number, top number, that's 7. The number of protons, remember that's the same as the atomic number, that's going to be 3. In a neutral atom, the number of electrons and the number of protons is equal, that's going to be 3 as well. And then you've got to remember that the number of neutrons is the mass number, take away the atomic number, 7 take away 3 is 4. Okay, next one. We've got 2311 Na. Easy enough to remember, hopefully. The top number, the higher number, is the mass number. The lower number is the atomic number. So the mass number is 23. The atomic number is 11. Number of protons, that's the same as the atomic number. Number of electrons in a neutral atom is the same as the number of protons. And number of neutrons is given by the mass number, take away the atomic number. So that's 23, take away 11. So there must be 12 neutrons, and I'll just score out my working there. So I think at least doing it in this format is reasonably straightforward. Hopefully you won't have any problems with that. The next page that I'd like you to do is a little bit easier. Sorry, not easier, I would say it's more difficult, because it requires you to do a little bit more problem solving, working backwards. It doesn't always give you the information in this nice neat format. So again, I'll just show you the first couple of examples. Okay, so next page. This time we are not given the symbol for the element. We're just given the atomic number and the mass number. Sometimes we're not even given, well, we're always given the atomic number and the mass number. Remember, the mass number is the higher one, atomic number is the lower one. To complete this page, you will need to use a data book. So I just have to find my data book now. Got it, right. So, if you're given the atomic number, to find the symbol for the element, you need to look in the periodic table. That's nice and easy because the elements are in order of atomic number. So if the atomic number is 4, just look along. 1 hydrogen, 2 helium, 3 lithium, 4 is beryllium. So I can fill in the symbol here. Atomic number 4, mass number 9. This is now just the same as we had on the previous page. The number of protons is the same as the atomic number, that's 4. Number of electrons, same as the number of protons, because the atom is neutral. And the number of neutrons is the mass number, take away the atomic number, 9 take away 4, so that must be 5 neutrons. In this next one, we're given even less information. We're not given the symbol, but remember, the lower number is the atomic number, so we can find the element in the periodic table. So this one's got atomic number 12. Looking at our periodic table, 12 is magnesium. And again, the rest of it is just the same as we have been doing in the last few examples. Atomic number is the lower one, mass number is the higher one. Protons, same as the atomic number. Electrons, same as protons. Neutrons, mass number, take away atomic number. Or you can always think about it as well as the higher number, take away the lower number for the number of neutrons. 24 take away 12, so that atom actually has 12 neutrons as well as 12 protons and electrons. I hope you get on okay with this. Any questions, please just make sure you let me know.